Hello, welcome back to the MCAT grind. It's a really quick and short chapter on membrane, specifically on osmotic pressure. It's really simple. It's just equals to I mRT. R is the gas constant, 8.315 for LATM. Or if you're going to use the one that's joules a lot more easily, it's 0.083 as R. Anyway, T is temperature in Kelvin, M is just concentration, I is the dissociation. So for NaCl, it dissociates into 2 ions, right? So there's 2. If it's calcium, it's just 1 ion and just 1, for instance, all right? And what else? Okay, so passive and active transport, you know the difference. Passive is you don't need to expend any energy, but active you do. Symport is when both the ion going in and another ion, they're both traveling in the same direction. So for instance, hydrogen ions may be traveling in the same direction as certain carbonate ions in the same direction. Antiport is opposite directions, where sodium potassium pump, sodium may coming one way and potassium may go into the cell. So they're traveling in opposite directions in that active transport. Cell-cell junctions, we have 3 main types. So gap junction is between 2 cells and they do a lot of communication and they can easily pass through items between them because these are connexins. 6 of them form a little central pore and they can pass right through the central pore. Tight junction is the opposite, where there is just 2 very tight walls together and it prevents any materials from seeping through the neighbors. And we have desmosomes. Desmosomes are basically the connections between the cell and its extracellular matrix, and just to connect the epithelial cell layers together. There are also hemidesmosomes, and they are also functioning similarly, but hemidesmosomes are more for connecting the epithelial cells to the basement membrane. And then we have the Nernst electric potential, which talks about the potential between the inside versus outside of a cell. Think about neurons, right? The electric potential will be negative 70 millivolts, for instance. So we have it should be R, gas constant, times temperature over ZF, Faraday's constant. But it could be easily simplified into 61.5 divided by Z. Z is the charge of the ion. So if it's sodium, then it's just plus 1, right? So just multiply by plus 1 or divide by plus 1. Now if it's calcium, then it's divided by plus 2. And the log of the concentration outside divided by inside. So if the outside concentration is 10 times that of inside, then just multiply by log 1. If they're exactly the same, 10 over 10, then that's log 1, then that's just 0. So there's no potential if it's the outside concentration and inside is the same. Goldman equation describes how if you have working with multiple ions and they'll have different permeabilities. P stands for permeability. You just multiply the permeability by the concentration, add that all together, and divide by the things all together at the bottom. Remember, we're using the inside as the reference. So outside is positive, and Cl, since it's minus, the outside is put on the down, and the inside is put on the top because it's counterintuitive, right? The more on the inside, the more negative it is, so the relatively positive outside there are. Okay, and same thing, multiply by 61.5, and you don't need the Z because you account for the different charges inside the bracket. So that's pretty much it for membrane. Quick and easy. Good luck.